Some of my previous videos I have been talking about analog electronics and different circuits using analog electronics. In previous video I have made a circuit which automates any electrical load, typically lightings, which is dependent on external light or ambient light, you can say. Today I have built a circuit which is controlled by the IR codes transmitted by any television remote like this. So I will send any kind of IR code and that would be received by this IR receiver over here, and that would control my light. So let's see how it gets on and off. Like this, simply like this. It gets on and off. So you might be wondering that this kind of TSOP1838 IR receivers actually give very high frequency output. So how I am dealing with it? And that's why this circuit is fairly complex one, and it is a industrial grade circuit. And what I mean by industrial grade circuit, that you can build this circuit to control any industrial instrument or to make any industrial product. That means it is some kind of product which is used by different companies, different industrial companies and such. So today we are going to look at how to build this kind of complex circuit. Now note that it is a fairly complex one, so if you do not get any part of it and if you don't know why I am doing that, you can always comment down below, or you can directly contact me, of course. And let's get started. So this is the very first and the most important thing in this circuit. It is a TSOP1838 IR receiver. Now it is basically a photodiode which just consists of a integrated circuit inside, which has a comparator, and it has a fairly complicated circuit inside. It has a comparator and a integrator inside. Now what is an integrator? An integrator is a circuit, analog circuit, built using an op-amp and some other analog components like resistors, capacitors, etc. It also uses a feedback loop. And this kind of circuit is used because this integrates the frequencies received by this IR receiver and integrates that into one single hexadecimal data, which can be interpreted by microcontrollers and microprocessors. So it has no output resistance, that means no pull down resistance or no pull up resistance. Now those who don't know what is a pull down or pull up resistance, that is simply a resistance which is either connected to ground or connected to power. Now if it is connected to power, that means in idle condition, it will pull its output up to the VCC, and if it is connected to ground or it is a pull down resistor, then in idle condition it will pull its output down to ground. That's all it does. Now it has three legs basically. The rightmost ones is the VCC, the middle one is the ground, and the leftmost one is the output. So in this circuit you can see that I have put it over here. The VCC, ground and the output are connected like this, and you can see that I have put a capacitor. Now it is an electrolytic one, and it has a value of 10 microfarads. Now its positive lead is connected to the VCC and the negative lead is connected to the ground. Now why it is connected? Now the connection is, of course, I would say it varies between the users, but it is recommended by the manufacturer that one should use this kind of capacitor in this circuit to eliminate noise. Now elimination of noises is required because when this kind of thing produces its output, it actually creates a noise in its input signal. So elimination of noise is necessary. And this is a 10 kilo ohm resistor. This one in front of you, it is a 10 kilo ohm resistance. It is connected to the ground. It is connected not to the ground, it is connected to the power directly. So it is a pull-up resistor. And there is another one, it is my output wire, which straight goes to this 555 timer, this small chip over here. This one is a 555 timer. Now this one is configured in monostable mode. Now why I am using it in monostable mode? Now most of you guys know that monostable mode of a 555 timer is known as a debouncing circuit. I am using it to lower the frequency, lower the output frequency of this infrared sensor. So what does this monostable timer does? It basically triggers its output high for a short amount of time, and in the meantime it takes no other input, so the output frequency gets lowered. Now I am using a 100 microfarad capacitor here to keep that response time what I need. Now you can go and experiment with the response time and capacitor value. For that I would recommend simply plug in a resistor and a LED in series with the ground and the output of this 555 timer. Now for that you will be able to debug your circuit. That's called debugging. Now this circuit takes in the trigger pulses sent by this IR receiver and lowers the frequency, and this output goes straight into the clock of a 4017 decade counter. This big chip over here, this is a 4017 decade counter. Now what does a decade counter do? A decade counter is simply an IC. When given a clock pulse, it will start counting from 1 to 10. Like when given one clock pulse, it will count 1. When given another one, it will go to 2, another one, and 3, and things like that. Now I have configured it to count in such a way that when the output, when the 0th position of the counting is not connected, that will not do anything. The 1 of the counting is my output, and that will that will turn on my transistor, and that will control my load, of course. And the 2 of the output, the 2 of the counter is connected with the reset. So whenever the counter counts to 2, the counter gets reset and it goes back to 0. So the counter is never able to count above 0. So from the output of this counter, I have connected a MOSFET transistor here. Now what is a MOSFET transistor? Now MOSFET stands for metal oxide semiconductor field effect transistor. Now you can note that term, of course. that stands for metal oxide semiconductor field effect transistor. Now, why I am using a MOSFET transistor? MOSFETs are typically greater than BJTs because they have much higher load connectivity, so they can handle much greater load than a typical BJT transistor. So, and they turn on just at 5 volts, so this 555 timer can handle it pretty great. So this transistor controls my 12 volt step up converter here. Now step up converter is connected with this 12 volt relay, and this relay controls this light. So let's try to use this circuit. I'm turning on the power of this light, so you can see the light is not turned on now. I have to turn it on by this remote. Oh, I have turned on the wrong switch. This one is here, and the bulb is on, off, on and off. And that's all for today. I hope you guys have learned a lot from this circuit. If you like that, comment down below, and if you have any other suggestions and any suggestions on what kind of circuit should I make next, then comment it down below.